class. Again, moving on with the lesson. So we're talking about logs. Um, my apologies if the link was not working. I fixed it. So double check if you didn't have a chance to look at the video before you do this one. Go back and look at it. We're moving on to lesson 22-3. If you look at the learning targets, making conjectures about properties of logs, and we're gonna write some the properties and then we're gonna apply it. So remember, by definition, logs and exponents are, they relate to one another. So if you notice how we're starting this off, they're kind of asking us to, you know, simplify this fact about exponentials. So if you remember, if you have this, as long as you have the same base and you're multiplying, this is the same thing as a to the power of m plus n. Again, as long as you have the same base and you're dividing, this is the same thing as a to the power of m minus n. So again, I hope you remember that from algebra 1. And again, power to a power rule, this is the same. So a to the power of m to the power of n is the same thing as a to the power of m times n. So just keep that in mind. There's a relationship between that and how the logs behave. So I'm just going to go ahead and use decimals to kind of give you an intuition. So um, let me go to decimals. So tell me what you notice. So I'm gonna in decimals, I'm gonna put this in projector mode. If you go to the function, functions, which is on bottom right, and if you choose miscellaneous, which is this one, the option all the way to your right, notice that you have the log feature. So I'm gonna do the log of 7 close parentheses um, plus log of 3. And notice again, just a number, right? And I get 1.322219 and so on. So notice what happens when I do the log of 21. And if you notice that I get the same exact value, 1.32221, then we'll talk about what that means. So, but yes, notice that I see the same thing. It seems that the log of 7 plus the log of 3. And remember, when there's no number in the bottom, the base is 10. So log base 10 of 7 plus the log base 10 of 3 is the same thing as the log base 10 of 21. So now let me write this one. Again, log base 10 of 7. This I'm going to do minus the log base 10 of 3. Notice that I get 0.37, 36, 79, 76, and so on. So notice what happens when I do the log of 7 divided by 3. Notice I get the same exact value again. So I get that. So we're going to look at those two for now. We're not going to do the third, the power to a power, but notice that log base 10 of 7 minus log base 10 of 3 is the same thing, is equal to the log base 10 of 7 divided by 3. So let me take a screenshot of this. And then let's go back to the lesson. So notice that there's a relationship that when we add, same thing as multiplying. And when we subtract, it's the same thing as division. So that's where that comes from, okay? So the book, if you look at the book, it kind of walks you through the process. So I'll show you that um, that the same thing is if you would do it graphically. So for now, let me just show you that. Okay, so I got log of base 2 plus the log base 10 of 3 is the same thing as the log base 10 of 6. log base 10 of 2 plus the log base 10 of 4 is the same thing as the log base 10 of 8. And the log base 10 of 2 plus the log base 10 of 5 is the same thing as the log base 10 of 10. And the last one, log base 10 of 3 plus the log base 10 of 3 is the same thing as the log base 10 of 9. So see, you see the pattern when we're adding, it seems like, and we use decimals, we multiply these numbers. Again, as long as we're adding, that's all we have to do. The same thing. We saw decimals that it gives us the same value. So in the book, that's what they tell us here. So it seems like based on the property, we know that when we have, and again, notice as long as we had the same base, the base that we don't see is a 10. So this is the same thing as log base 10 of m times n. If you want to put that in parentheses, that's fine too. Notice that decimals does that. So the only thing I'm going to add here is the, if I have log base b of m plus the log base b of n is the same thing as the log base b of m times n. Again, notice that as long as you had the same basis, you can simplify it. So log properties. And the same thing when we did division. So notice that we subtract when we divide as long as with the same base. So then the other property was this, log base 10 of m minus the log base 10 of n is the same thing as the log base 10 of m divided by n. Okay, if you want to put parentheses on that, that's fine. Notice that the bases are the same. The base that we don't see is at 10. Or you can also the log base b of m minus the log base b of oops, of n is the same thing as the log base b of m divided by n. Again, notice that as long as the bases are the same, we can make that conclusion. And I'm going to post, oh, that's my son right there, playing around. As a reference. So in our notes, I'm gonna put that in here so that we can remind ourselves. We use decimals to show that that's true. Again, when we add, we get the same results. And when we subtract, we also get the same results. So those are two properties that we're going to be looking at of logarithm. Okay. One more thing I want to do, I want to show you the same thing in decimals. But if I have a graph, so notice that I'm going to have an equation. Y is equal to log of x plus log of 5. But what happens if I write it as y is equal to the log of 5 times x, which is 5x. Notice that I get the same graph. You see how they overlap is the same graph. Same graph. So you notice it's giving me the same work. Or what happens if I have, so let me hide these two right here. y is equal to log of x, oops, minus the log of 8. Notice this is what I get to get my graph. What happens if I write it using the properties, which is y is equal to log of x divided by 8. So notice that I get the same graph. Oops. I get the same graph. So notice that visually I see there's the same graph. We use the calculation of decimals. We got the same values. So this is another way to show like all the properties of logs. The properties meaning these right here. So we got when we're adding something as multiplying, and when we're subtracting something as division. So we see numeric values are identical, and then we saw the graph is also identical. So with that, um, this is where I'm going to stop. I'm gonna put the page numbers on the book, but essentially is this is the same idea. We're gonna for sure do more work on this. Um, and again, if you have any questions, make sure you log on to my office hours each Friday, and then bring your questions.